Hi everyone. So today we present you with a weekly insight on analyzing water quality for TDS simulation in WaterGEM Connect edition. So before proceeding further, I would like to give a brief intro about our company. So Capricorn Technology is a Win Zero company, which is having a legacy of over 3 decades, has now become a partner of choice for the AEC industry. Capricorn Technology is one of the biggest platinum partner of Autodesk and Bentley, along with authorized training center. So today, with over 10 offices across India and 300 plus expat team member, we are serving over 20,000 customers in the building, infrastructure, manufacturing, along with a large number of other industries as well. So let me introduce myself. So hey, this is Pranjal Verma, working at Capricorn Technology as a solution specialist for water and wastewater. New Delhi will present you with a weekly insight today. So the objective of this insight is to analyze the water quality monitoring for our distribution method. There are different methods present in WaterGEM for water quality analysis. Like we can analyze the chlorine simulation, then we can also create a water age analysis. But in today's insight, we are going to cover a TDS simulation for distribution method. So basically, which allow a water utility to monitor and analyze the concentration of dissolved solid in their distribution system. So basically, the information is crucial for ensuring the compliance with the regulatory standard and maintaining the high water quality. So what we are going to do is, firstly, we'll be set up the alternative and constituent for the TDS simulation. Then we will create a scenario, obviously, for computing the result, and then how we can analyze the result with the help of color coding within the network. So I'm just switching to other software and give you a live demo about how we can analyze the water quality for TDS simulation. Okay, so let's suppose this is my sample distribution network and we have to analyze a TDS simulation within this network. So as I said before, first we have to create an alternative for the constituent. So I'm just going to alternative under the analysis tab over here. Then we'll find a alternative. Just expand the constituent alternative category and we have to create a child alternative. So how to create a child alternative, just right click on the default constituent and from here you can find out that new and you can create a child alternative. I have already created a child alternative and name is as a TDS 300. I'm just going to double click on it to open the constituent tab. Now what we have to do is we have to also create a constituent for the TDS. So over here you can see the ellipse icon. Just open from this here and from here you can create a new label for the TDS 300. From here you can create a new label and I've named it as an TDS 300 and make sure that diffusivity for the block would be same as the equation has been seen in my window, and it is also being confirmed that the unlimited concentration checkbox is checked. Since the TDS 300 is a conservative constituent, so the reaction rate, bulk and wall decay coefficient were 0. So I'm going to just close the constituent TDS dialog, and from here then you can select the TDS 300 that we have just created. Now what we have to do is we need to set the concentration for the TDS in the source of water. So if you are having the reservoir or if you are having a tank, you can give the value. So I'm having the both. So I'm just clicking on this reservoir and then I have put the value in the concentration initial as in 250 and 600 for the two reservoirs. So you can also give you according to your need. I've just given the random value. Then just click on the tank option if you are having the tank in your distribution method and give the value for the same for the concentration initial and for the both the tank. The next thing what we have to do is we to run a water quality simulations, the calculation option must be set up for calculation time, run duration, and time setup. So I'm just going to close this. So we have to set up a new steady state EPS solver calculation. So how to do this? Go to analysis tab. Here you'll find the option. Under the option, just highlight the steady state EPS solver, and from here you can create a new. I have already created and I have named it as an constituent analysis. Just double click on it. You can see the property for the same has been docked on my right window. And then from here, make sure the calculation type should be selected as an constituent over here. And also make sure that simulation start date also you can from here select the date, and you want to set the time, you can also set the time. Then as I duration for 288 hours I have indicated in solver. So I have given the duration for 288 hours. And so these type of input are mandatory for you. So I'm just going to close it. Next, what we have to is we have to create a scenario to set up the scenario that incorporate the TDS 300 water quality alternative and calculation option, and we can run the analysis. So how to create a scenario? Under the analysis option here, you'll find a scenario. Similarly, as we have created the child alternative, so here also we have to create a child scenario. Just right click on the base scenario, and from here new and child scenario I have already created, and I have named as a TDS 300. Just double click on it, and same for the property of the TDS 300 scenario has been talked on my right window. So from here, make sure your demand should be assigned according to unit. I have assigned for the peak hour. Then from here, constituent must make sure the constituent should be selected at TDS 300. And the one thing, the calculation option that we have created before should be selected as an constituent analysis 288 that you have created before. And just make this current, just highlight this, and from here you can make the current and just compute it. It will take a few time. So my result is being true for all the hour that I have described in the calculation option for 288 hours. Just close this to set up the color coding to view the TDS concentration in the drawing and how they fluctuate over the time. You can do it how with the help of symbology. So here you can find a symbology in the view option. Here it is a symbology option. I have already docked it on the right window of my site. Just highlight the pipe, right click on it, and new and color coding. So you'll find the color coding property dialog box will be appear something like this. I have already created. I'm just double click on it. So from here field name, you can select the concentration calculated. Then from calculate range, you can go for the full range. In option, you can go for the color or color and size. And then you have to give the value. I have given the random value 260, 300, 400, 500, 625. And from here in the ellipse icon, you can select the color as well for the different value. Just apply and okay. So as I click and check both the concentration, you will find that my distribution network has been changed. Now to see the animation result, what we have to do is like we can see the fluctuation over a time. Just go to the analysis option. Here you can see the option times. Just click on it and just I'm going to play a button. You can see my distribution method is being changing. So this is how you can analyze the TDS concentration within your distribution network with the help of color coding. I hope you guys had an insightful session. So do subscribe to our YouTube channel for all updates. We would be delighted to hear from you. So do reach out to us for any suggestion, query, or topic you would want to discuss. Thank you. See you next week in the next with the next insight.